Hi everyone, so from this video onwards we are going to start studying about integral calculus. But before we need to study two important terms which are flux and flux density. So first we are going to study about flux. So what do you mean by flux? So let's just say from my face vector field lines are coming. My face is giving vector field lines. And this is a surface I am assuming. This is one of my surface. Okay. And my field lines are coming vertically. In this manner it is coming. Right into your screen. I have shown cross here. What do you mean by cross? Going into your screen, right? So it is going into the screen. So this is how the field lines are coming. Now this is the surface. This is one surface I am assuming which has a surface area of S1. It has a surface area of S1. So now if this is my surface area and field lines are coming in this manner. So this is one of the field lines. One field lines I am showing. This black pen. This one of the field lines I am showing. So there would be thousands of field lines like that. Now this is my face and thousands of field lines are coming in this particular paper and that is flowing out. Okay. So now how many field lines are coming? Thousands of field lines are coming. Let's just say 1000 field lines are coming. That is going out of the paper. Now if I start rotating the paper, now can you see my face? No, you cannot see my face. If I start rotating the paper, now slowly you are able to see my face, right? Slowly you are able to see my face. Slowly. So whatever the field lines that are coming from head, that is not passing through this paper, right? Which are coming from head, that is not passing through this paper. They are going away from they are going ahead of the paper, right? They are going up from the paper. Now if I do it like this, till here if I have done. Now I started from here and then I made it something like this. How many field lines are passing now? How many field lines are crossing this particular surface area? This surface area I am talking about. How many field lines are crossing this particular surface area? This is not crossing the surface area, right? Now it has become something like this. It has become something like this. And field lines are going like this. So field lines will be going on this, but it will not be cutting it. Initially it was cutting it. It was cutting, the field lines were cutting and it was passing from here. Now field lines will be going in this manner. In this manner. From upper side, from lower side. But it will not cut it. So how many field lines are going? How many field lines are passing? 0 field lines are passing. In this situation, this was the direction of field line. This was the direction of field line, right? This is the direction of field line. And what was the direction of surface? The direction of surface is perpendicular to the surface area. So this was the surface area. The direction of surface was this. This was the direction of surface. This was the direction of field line as well. What was the angle between them? This was the direction of surface and this was the direction of field line as well. What was the angle between them? 0 degree. So the angle between them was 0 degree. At that time maximum flux was passing. So when angle between surface unit vector which is perpendicular to surface. So when the angle between surface unit vector and vector field is 0, maximum field lines will pass. And when it is 90 degree, that means at this time, what was the angle? What was the angle between vector field lines and surface unit vector? Surface unit vector means perpendicular unit vector I am talking about. What was the angle between perpendicular unit vector and vector field line? This was your perpendicular unit vector and this was your field line. What was the angle? 90 degree. So at 90 degree, 0 flux was passing. So what did you understand? Initially both were inclined on each other. Then both went like this. So what do you think? What happened there? The angle increased from 0 to 90 degree. Right? Okay. Now let's define. We will come back to this point. This point you need to remember. 0 degree maximum passed. 90 degree 0 passed. We will come back to this point. Okay. We will relate this thing to first lecture. What we studied there, dot product. So that we will relate. But first let's study about field density. What do you mean by flux density or field density? Mobile अपने आप बजने लगता है. Yeah. So what I was saying, what do you mean by field density or flux density? So flux density is number of field lines passing through a surface but per unit area. Number of field lines that is passing per unit area. Per unit area, how many field lines are passing? That is known as field density, or you can say flux density. Okay. So flux per unit area also you can say, or number of field lines passing perpendicularly through per unit area, that also you can say. Okay. Now what I am gonna do is that I am gonna assume per unit area I should denote by S, okay, and flux density I am denoting by E. Flux density I am denoting by A, area I am denoting by S. This is the area. Now I am gonna assume a small surface ds here. I am gonna assume a small surface ds. Now let's just say one field line is passing from this small surface ds. One field line is passing from this small surface ds. Okay. Now I know that my flux density is A. What do you mean by that? In 1 meter square area, A field lines will pass. My flux density is A. That means in 1 meter square area, A field lines will pass. Are you agreeing to this point? No, you do not understand this point. Again, let me explain it. How do I explain it? Look, if you put S equals to 1 meter square, what you are going to get? A is equals to 5. So this thing you know that in 1 meter square, 5 flux will pass. In 1 meter square, 5 field lines will pass. And 5 is equals to A only. So that means in 1 meter square area, A field lines will pass. So in ds area, how many field lines will pass? In 1 meter square area, A field line will pass. Because if I put S equals to 1 meter square, then A will be equals to 5. That means in 1 meter square area, 5 field lines were passing. And that is equals to A only. So in 1 meter square, A field lines will pass. So in ds meter square, how many field lines will pass? A into ds. In ds meter square, A into ds field line will pass. Now ds was a small area. If I need to find from the complete surface area how many field lines are passing, if I need to find from the complete surface area how many field lines are passing, then what do? I will integrate it. Say yes or no. So the formula is becoming A into ds integration. That will tell you total flux. The formula of total flux is coming out to be, this is your total flux. From ds surface, from 1 meter square area, A field lines were passing. If I assume ds a small area, from a small area ds, how many field lines will pass? From 1 meter square, A field lines were passing. From ds meter square, ds into A, or you can say A into ds field line will pass. Now if I need to find from the complete surface how many field line will pass, so what do I need to do? Integration. So from the complete surface how many field line will pass, what that is known as? Flux. So my flux is equals to A into ds. Even if you did not understand it, you just need to remember it. Flux density into ds, that's it. But we will use dot product here. This is vector field, this is also a vector quantity, and ds is also a vector quantity. Why we are using dot product, why we are not using cross product? Think about it. Take 30 seconds and think about it, why we are using dot product. Hint. Very easy, right? You get to know that when both were inclined towards each other, then the maximum flux was passing. And when 90 degree is angle, then 0 flux is passing. So cos 0, maximum, that is equals to 1. Cos 90, 0. So when 90 degree angle is there, 0 flux is passing. When 0 degree angle is there, maximum flux is passing. Okay. So again I repeat the derivation. Derivation is not important, the final result is important. So what did we do? We understood about flux density. In 1 meter square, how many field lines are passing? That is known as flux density. So in 1 meter square, A field lines are passing. In 1 meter square, A field lines are passing. Now I need to find how many total field line will pass. How many total field line will pass through this surface? So what did I do? I took a small area ds. So from 1 meter square, A field lines are passing. So from ds meter square, how many field lines will pass? A into ds. So how many field line will pass? A into ds. So from the complete surface, how many field line will pass? A into ds integration. And once I do this integration, from the complete surface, how many field line will pass? I get that value. And that value is equals to flux only. And I will use dot product here. Why I am using dot product? Because if angle is 0 degree, then maximum flux are passing. If angle is 90 degree, then 0 flux is passing. So I will be using dot product here. So what did you get the formula? The formula of flux is coming out to be flux density into flux density dot ds. The dot product between flux density and ds. Vector field density you can say, or vector flux density also you can say. Okay, flux density also you can say, or field density also you can say. Dot ds, and then you do the integration. Limit you will put as per this ds. Are you getting this point or not? Did you understand this point or not? Okay, I hope you must have understood. I spent more than 10 minutes and I hope this is clear to you. So this is what we call as flux. Okay, so let's solve the questions now, because this chapter will be completely based on problem solving only. So let's solve this question. The field density, don't try it on your own, first I will solve it, then you will be able to understand. This is the field density given, or flux density is given. Determine the flux out of the flux of G out of the entire surface of a cylinder with radius 1 unit and height 1 unit. So this is the radius, which is 1 unit, and height is also 1 unit. This is your flux density. You need to find the total flux that is going out of it. So what you need to do? G into ds you need to do. But there are total 3 surfaces, right? Which all 3 surfaces? Top, bottom, and curved. I am calling this surface as curved. Top, bottom, and curved. This water bottle you can see. Okay, top, bottom, and curved. So this is a field density. This is a field density. Arrow AZ is there. So some field density is there. Like some field lines are going in this manner, in that manner, in that manner. Some are going like this. Some are going like this. Some are going like this. Some field density is there. I showed you a waveform. I should not say waveform. I showed you a vector field, right? When we studied the assignment video. In that assignment video, I showed you a vector field by simulation. So there you saw that a lot of field lines are going here and there. So similarly, a lot of field lines are going here and there. You need to find how much total flux is passing through this particular bottle or from this cylinder. So top, bottom, curved. 1 unit radius, 1 unit is height. Okay, so there are top I am calling as T, bottom I am calling as B, and curved I am calling as C. So this is the flux I need to find. So first I will find from top, then bottom, then from curved. Okay. So total flux is this. Phi total is phi C plus phi T plus phi B. So let's find first phi T. Flux from top surface. Now you should be able to tell me what is the equation of this surface. Please tell me what is the equation of this surface. Think about it. Surface, this is a surface, okay? This is a surface. So what is the equation? Here rho is changing, right? Rho is different here, the rho is different here, here rho is different, here rho is different, here rho is different, rho is changing. Phi is also changing, phi is also changing, phi is also changing. 0 degree to 2 pi. What is constant here? On this surface, Z is constant, which is equals to 1. Here it should be given that it is Z equals to 0, but in the diagram also you can see it is Z equals to 0 only. So here Z is constant. So the equation of this surface is Z equals to 1. So flux from top surface, what is the equation? This is our first task. We need to find the equation. If we are not able to find the equation, then forget about the equation. You will not be able to solve it. So Z equals to 1 is the surface. So can I write down the ds for this? Ds for top. What will be the ds? Look, what I need to do. Roughly I will write d rho, arrow cap. Roughly I will write the dl length. Although you will build the practice, so in the examination you will not have to write it. But here for understanding it or for explanation I am writing it. This was your dl. I hope you must have studied the coordinate geometry, then only you will be able to understand these things. Now what will be your surface area? What is the direction of this surface area? Az cap. Whether you will take az cap or minus az cap, how will you define? Look, there could be two perpendicular vector, az cap and minus az cap. Which one will you take? Do you remember anything? Did I tell you anything? Whenever you see a closed surface, close, this is enclosing some volume, right? Whenever you see a closed surface, then the direction will be always coming out of the volume. It should not be going into the volume. This is going into the volume. No. We will always take coming out of the volume. So my direction will be AZ cap. What will be my DS? Drop DZ and write down both. Drop AZ cap and then write down both. So rho d rho d phi, rho d rho d phi, AZ cap. This will be your DS. Okay. So what will be your phi t? So this is your G, that is tan e to the power minus 2z, tan e to the power minus 2z, rho aero cap plus AZ cap, rho d phi AZ cap, and then rho is changing from 0 to 1 and phi is changing from 0 to 2 pi. Okay, this shows flux, this is other phi. Okay, don't get confused. This is the phi, that is angle, and this shows flux. Here the value of z is fixed, that is z equals to 1. So I can put z equals to 1 here. Z equals to 1 here I am putting. Now AZ dot arrow, that will be 0. So AZ dot AZ will be there. Are you getting this point? I will first see this particular expression. Okay, this will be again and again used. So if I am doing dot AZ, then directly I can write down the expression. No, because I know this expression will go to 0. So expression will be tan e to the power minus 2z. So expression will be tan e to the power minus 2z. Tan e to the power minus 2z. Z value is 1. Now this expression will go to 0 and then rho d phi, and phi value is going from 0 to 2 pi and rho value is going from 0 to 1. So tan e to the power minus 2 will come common. Rho d rho, what is the limit? 0 to 1, and then what is the limit of phi? Phi limit is from 0 to 2 pi. So what you are going to get here, tan e to the power minus 2 into rho square by 2. Rho square by 2 you will put, then you will put the limit. So what you are going to get, 1 by 2, and here you are going to get 2 pi. So tan pi e to the power minus 2. So this is the flux that is going out of the top surface. Are you getting this point? What did I do here? First I wrote down the equation, then I saw the direction, no issue about it. Then I need to write down the surface area. So from here AZ cap is coming, so I will drop AZ. This I have already told, this I have already taught in very detail when we were studying coordinate geometry. So I wrote down this rho d phi. So rho d phi AZ cap. Okay. Now I need my GR function. So here only I will write down GR function again. That is tan e to the power minus 2z rho aero cap plus a phi cap. Right. Then ds will be rho d phi az. Sorry, this was az cap, not a phi cap. This was az cap. Okay, yeah, az cap. Now I need to do the dot product. In between there is dot product. This dot I forgot to show. So az dot arrow, that will be 0, and az dot az, that will be 1. Did you understand this step? Tan e to the power minus 2 rho aero cap into rho d phi dot az cap. Basically aero dot az, this into is dot. So aero dot az, that is becoming 0. So that's why I did not write this step. Okay, I hope now people are able to understand. Aero dot az, I did not write this step. Then in the next step what will happen? Tan e to the power minus 2 az cap rho d phi az cap, and az cap will become 1. Az cap dot az cap, that will become 1. So tan e to the power minus 2 rho d phi. So tan e to the power minus 2 is coming outward. Rho square by 2 0 to 1 and d phi 0 to 2 phi. So this is the answer we are getting. Okay. Now try it on your own from the bottom surface. Let's find from the bottom surface phi b. What is the equation of bottom surface? What is the equation? Z equals to 0. Same thing is there. Here also rho is changing, here also phi is changing, z equals to 0 is the equation. What will be the direction? Minus az cap. Say yes or no? Perpendicular direction would be this and this. But which one will you take? Which is going out of the volume. So going out of the volume is downward. So upward is az cap, downward is minus az cap. So direction is minus AZ cap. No doubt about it. Okay. What will be your DS? Rho, d rho, d phi, AZ cap, but minus sign. Rho, d rho, d phi, AZ cap, minus sign. The same DS will be there. I need to calculate phi t. Sorry, phi b. Sorry. Phi b. Two limits will be there of d rho and d phi. Two limits will be there. Tan e to the power minus 2z. What is the value of z? 0. Rho d rho d phi. Wait a second, I forgot the next term. What was the term here? Rho a rho cap. Rho is changing here, so I will not do anything with rho because rho is changing. Z is constant, that's why I put the value of z. I did not put the value of rho. Rho is not 5. Rho is changing on the surface from 0 to 1. So rho is changing, that's why I did not do anything with the rho. Plus AZ cap. Rho d rho d phi minus AZ cap. Again, a rho dot AZ cap will be 0. Here you can use dot product. So tan e to the power minus 0 will be 1 only, and a rho dot AZ cap will be 0. So forget about that. So you only need to take AZ cap dot AZ cap. So what you are going to get? D rho d phi and a minus sign. Are you able to understand this calculation? First, just do the dot product between these vectors. What you are going to get? Rho a rho cap plus AZ cap. All are in multiplication, no? So dot product I am going to do between them. So what I am going to get? Rho a rho cap dot AZ cap plus AZ cap dot AZ cap. This minus sign I have taken here. Forget about the minus sign. So what you are going to get? This will be 0 and this will be 1. So the result of dot product is 1 between this and this. Result of dot product is 1. Is that clear to you? Yes. So result of dot product is 1. Rest all terms I am writing only. 2 e to the power minus 2 into 0. That will be 1 only. Here rho d rho d phi. So tan rho d rho d phi. So phi value is going from 0 to 2 pi and rho value is going from 0 to 1. Anywhere you can write down the limit. Just rho limit will go to rho and phi limit will go to phi. So tan rho square by 2 from 0 to 1 and then phi 0 to 2 pi. So 10 by 2 into 2 pi. So that will be 10 pi. So here it is 10 pi. Okay, this is the second. Then curved also you need to write. Curved. What is the equation of curved surface? Look, this is the curved surface, right? Curved surface. Curved surface. This is actually a hollow cylinder. They should write it. From entire surface they are asking. From entire surface they are asking. So what is the equation of this curved surface? Do you remember it? Z is changing. Z is changing from bottom to top. Z is changing on this curved surface. Phi is also changing from 0 to 2 pi. Phi is also changing. What is constant? Rho is constant. In between there is no material. From surface you are finding. At the surface rho is constant. No. At the surface rho is constant. Say yes or no. I am talking about surface only. I am not talking about total inside what is there. No. At this complete surface rho is constant. No. Rho is equals to 1. So what is the equation? Rho equals to 1. This we have already seen. I am explaining too much. I know most of you guys would already be knowing it. And what will be the direction? Direction will be radially, starting from here, radially outward. This will be the direction. At this point radially outward, 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 at this point radially outward. So direction will be radially outward. That would be arrow cap. Direction would be arrow cap. I need to add a page. So what will be my DS? So forget about d rho. Rho d phi dz. Rho d phi dz. Okay. So what will be your phi curved? Z is changing here, so I'm not gonna do anything with Z. But rho is constant here, so I can put the value of rho here. Rho equals to 1. So tan e to the power minus 2Z. Tan e to the power minus 2Z. Since Z is changing, I'm not going to do anything with Z. Rho is constant, that is 1 only. A rho plus a phi. Then what is the value of ds? Rho d phi dz. Rho d phi dz. Forget about everything. First do the dot product of these two. So a rho plus a phi dot a rho cap. So a rho dot a rho 1. A phi dot a rho 0. So 1. Okay. So result is coming 1. So what you are getting? Tan e to the power minus 2z. Rho is there, d phi is there, dz is there. Again I will write in the good manner. Tan rho. Okay, rho value I can put no. Wait a second, did I do anything wrong? Rho d phi, yeah. Rho value I can put. Why I am taking these? So rho equals to 1 I will put here. Rho equals to 1. So only limit will be of d phi and dz. So tan into d phi. Tan is constant and only d phi term is there, and phi is going from 0 to 2 pi. And then tan e to the power minus 2z into dz. Z is going from 0 to 1. So what we are getting here, tan will be coming common. This will be 2 pi, and here this is not tan. Tan has been already taken here. No, all are in multiplication, so tan d phi has been already taken. E to the power minus 2z dz. So what you are going to get? E to the power minus 2z divided by minus 2, 0 to 1. Right. So you are going to get tan pi. First you will put 1 minus e square. So your answer is tan pi minus tan pi e to the power minus 2. Did you understand this point? Yes. Simple integration is there. Tan pi tan e to the power minus 2. Tan pi e to the power minus 2. So what is the total flux? Total flux is tan pi e to the power minus 2. Tan pi e to the power minus 2 plus second you are getting tan pi. Tan pi e to the power minus 2, and third was this plus tan pi plus tan pi here. I forgot the minus sign. Minus sign was there. No? Minus sign was there. So this was minus tan pi. I forgot the minus sign here. This was minus sign here. So let's not make the minus sign. This from this dot product I was getting 1, but I forgot the minus sign. So this was minus tan pi. So let me write it down in a better manner. So this was minus tan pi. This was minus tan pi. So this was minus tan pi plus tan pi minus tan pi e to the power minus 2. So what is the total flux you are getting? 0. So total flux is 0. That's the answer. Okay. Now you are thinking, sir, how we will be able to solve this kind of question in the examination? You will be able to solve once you have the practice. At least we are going to solve 30 questions. I am telling you. You will get enough practice. And later on I will tell you a theorem. By that theorem it will be done in just one page. Since this is a closed surface, so it will enclose a volume. If it is enclosing a volume, then you can apply divergence theorem here. So that I will be telling later on. Okay, do not worry about that. So that I will tell later on, but you should also have this ability to solve the problem in this manner. So till now we are not going to, in this lecture we are not going to solve any problem with any theorem. Just by pure concept we are going to solve it. So pure concept I have applied. Write down the equation of surface, wrote down the equation of surface, see the perpendicular vector, write down the surface area, do the dot product, take care of the signs, take care of the calculation, put the limit and find the integration value. In that manner you go, see all the surfaces and you will be able to get the answer. Okay. Let's see the new topic. I should not say new topic, just some concept. What is this? What is this called? Open line. This is an open line. This is an open line. Now what do? I take 3 lines like that, 1 line, 2 line, and the third line. 1 line, 2 line, and the third line. What this has become? A triangle. One, two, and the third one. So this has become a triangle. This is known as closed line. What this is known as? Closed line. What is the interesting thing here? There is nothing in between. Here there is nothing. Here there is nothing. Here there is nothing. You just took 3 lines, 1 line, 2 line, and 3 line. You just took these 3 lines and you made this surface. You took a wire and you just made this circle. You took 4 wires and you made this rectangle or square, you can say. So there is nothing in between. Are you getting this point? 1, 2, 3. There is free space in between. There is nothing in between. 1, 2, 3. There is nothing in between. This is the important thing here. Okay. So the closed line will enclose a surface area. This will enclose a surface area, right? This surface area it is enclosing. There is nothing in between, but at least this much air it is enclosing, no? This closed line is enclosing this much of air. This is enclosing this much of air. There is no material in between. There is no material here, but it is enclosing this much of air. So you cannot call it surface. Nah. This is not surface because there is no material in between. So this is known as closed line. So there is high difference. I will tell you what is surface. So this is known as closed line and this is known as open line, and closed line will enclose a surface area. So what is the difference between a closed line and a surface? So this was your closed line and this is known as open surface. Open surface. This is known as open surface. So this paper, this is an open surface. This is an open surface. This complete paper, this is an open surface, right? Because in between there is a material. So this is the material. In between there is a material. Here no material. But it will enclose some surface area, right? So this is your open surface. Open surface. Now what do? I take these kind of 6 surfaces and from there I can make a cuboid. I can take these kind of 6 surfaces, 1 here, 2nd here, 3rd here, 4th here, 5th here and 6th downward. I can make something like this. This is a multimeter, but 1 surface, 2nd surface, 3rd surface, 4th surface, 5th surface and 6th surface. Just consider in between there is nothing. In between there is air. I took 6 surfaces. I took this 1 surface, 2 surface, 3, 4, 5, 6. I took 6 surfaces. Okay, and I made a cuboid. Right? So this is known as closed surface. This is not known as volume. Are you getting this point? This is known as closed surface, and closed surface encloses volume because it will contain some air. 2, 3, 2, 4, 6. 6 surface I have made. Sphere can also be an example. Sphere can also be an example. Consider this as a sphere. This is not circle, this is a sphere. So sphere can also be an example. Sphere can also take some air. So you can also make a sphere. So that is also a closed surface. But if there is some material in between, here there is no material. No material. No material in the volume. Here there is no material in the volume. You just took 6 surfaces, you just combined them and you made this structure. So there is no material in the volume. Okay, so there are a lot of examples. I hope you must have understood. This was an open line. This became a closed line. Okay. This was a closed line. This was a open surface. One open surface. And when you made 6 surfaces like this, that became closed surface. And closed surface is enclosing some volume. That's it. Is that clear to you? We will take more examples. It will become more clear to you. No need to worry about that. Okay. So if I am making this sign, that means I will call it open line integration. Okay, or I will simply call it line integration. Open line integration you can say, or simply line integration. If I have made this circle here, that means I am talking about closed line integration. That means I am talking about this integration of this particular closed line. That means what is the sign of arrow? This is the sign of arrow. So first I will go from this point to this point, then from here to here, then from here to here, and then from here to here. In that manner we will go. Here in this particular circle we will work on the circumference. Here also we will work on the circumference. So basically closed line integration means you need to work on the circumference. Open line integration, simply you need to go from here to here. Closed line integration means you need to work on the surface. Similarly, there is open surface integration, or directly surface integration you can say, and closed surface integration, and then volume integration is there. We will see the examples, it will be clear to you. No need to mug it up, just understand what do you mean by open line, closed line, open surface, closed surface, and the volume. Is that clear to you? Okay, we will see the problems, no need to worry about anything. So this is the sign, this shows closed line integration. This circle shows closed surface integration. This is the important point. What is the difference between this and this? Actually, surface integration is shown by two integration sign, and volume integration is shown by three integration sign. So here I have made two integration sign. Okay, and let's make it more clear. Let's solve some questions, it will be more clear to you. So you need to find the charge contained by the ring of radius 5 meter having a charge density of 5 rho coulomb per meter. I know this lecture might seem a bit tough to you and you are not able to solve the problems. It might happen to you. But slowly you will build up the concept. When we go to the assignment, till that time you will be much comfortable. So this is one of the video, one more video will come. So after that you will be much comfortable. Okay. So there is a ring. This is the ring. Okay. So there is a ring which has a radius of 5 meter. Actually this is circular. The ring is circular. They are saying ring. So it is a circular ring. I don't have any circle with me. So this is a circular ring, but why I have made like ellipse? This is lying here. So forget about it. Why I should confuse you? If this is circular, I should make circle only. So the ring is like this. Circular. They did not say disc. What is the difference between ring and disc? This is your ring, but this is your disc. Disc will enclose some area, but this will not enclose any area. This is your closed line, and this is your open surface. Are you getting this point? Ring and disc. So I will just show it here. This is your ring, and this is your disc. This is known as closed line, and this is open surface. So there is difference between both of them. It is not enclosing any area. Sorry, it is enclosing a surface area, but in between there is no material. Now what they are saying, it has a radius of 5 meter. Has a radius of 5 meter and having a charge density of 5 rho coulomb per meter. Charge density. Have you heard this term charge density? No. But can you see the unit? Yes, coulomb per meter. That means on 1 meter 5 rho coulomb is there. Sorry, 5 rho coulomb charge is there. On 1 meter 5 rho coulomb charge is there. Did you understand this point? On 1 meter 5 rho coulomb is on 1 meter 5 rho coulomb charge is there. So can you tell me how much charge will be there on DL length? If I take a DL length, then how many charge will be there? 5 rho DL. If I take a DL length, then how much charge will be there? This is the DL length I am taking. On 1 meter 5 rho coulomb is there. So on DL length 5 rho DL coulomb charge will be there. And if I need to find what I need to find? Find the charge contained by the ring. If I need to find the total charge, if I need to find the total charge, what I need to do? I need to do the integration of this 5 rho dl. On dl, on 1 meter I know there is 5 rho coulomb charge. On dl meter there will be 5 rho dl coulomb charge. On the complete, how much charge will be there? That I will have to integrate. Is that clear to you? Think about it. What will be your dl? I need the answer. What will be my dl? Rho d phi. Why is that so? Because here on this length, on this circle, what is constant? D rho is constant. Rho is constant. Rho is constant. What else is constant? Z is also constant. But what is variable? Phi is variable. Phi is variable. So if phi is variable, what is the complete length? D rho a rho cap plus rho d phi a phi cap plus dz az cap. So if phi is variable, then rho d phi will be your dl. So my dl will be rho d phi. dl will be rho d phi. And from where to where limit will go? Start from anywhere. Rho will start from 0 to 2 pi. It will take a whole turn from 0 degree to 2 pi. So the limit will go from 0 to 2 pi. Rho value is constant, rho is 5 meter only. So 5 rho square I can take outward, then d phi from 0 to 2 pi. The answer is tan pi rho square. The value of rho is constant only. So 25 250 pi. What I did, I put rho equals to 5. On this closed surface, rho is constant. So what it is saying, on 1 meter, 25 coulomb charge is there. Did you understand this point? On 1 meter, 5 rho coulomb is there, but rho is constant here, no? So in 1 meter, 25 coulomb is there, because rho is 5 meter. So here you put 5, so 25 coulomb charge is there. So on 1 meter, 25 coulomb charge is there. What is this complete circumference? 2 pi r. So on 2 pi r meter, 2 pi r, or you can say 2 pi rho, and rho value is 5. So this complete circumference is 10 rho. Complete circumference is 10 meter, 10 pi meter, sorry, 2 pi r it is. This complete circumference is 2 pi r, 2 pi rho you can say. So rho value you put 5, so what it will be? 10 pi. So in 1 meter, 25 coulomb charge is there. So on 10 pi meter, how much charge will be there? 250 pi coulomb. So this is also, you could have solved it. 250 pi coulomb charge is there. Are you able to understand? Look, I need to introduce these things, then only you will learn. If I had solved by this, you would be able to think, okay, it is very easy, this is simple mathematics. Charge density means on 1 meter, 25 coulomb charge is there. But why you will be able to, why here you are able to put the value of rho? Because you know that on the circumference, rho is constant, and you need to find the charge on the circumference itself. But in the circumference, what is changing? Phi is variable. That means my length will be taken as all these graphs we have made in coordinate geometry only. So if my phi is variable, then what will be my small length? That will be rho d phi. Right? So what will be the total charge? 5 rho into dl, and dl is rho d phi. So rho value is changing from 0 to 25. Why I am writing 25? It is from 0 to 2 pi. Phi value is changing from 0 to 2 pi. So 5 rho square will come outward. So this will be 10, and limit is from 0 to 2 pi. So it will become 2 pi only here. So 250 pi is the answer. Okay, well and good. Yeah, let's see the next one. Try doing it on your own. What this circle means? You need to find the closed line integration. Now you will have the question, sir, from where to start? From anywhere you can start. I will start from point A. From anywhere you can start, you will get the same answer. But walk along the line. It is asking you to go from A to B, then B to C, then C to D, and then D to A. So you need to walk along the line, and then you need to find the line integration. So now we are solving line integration problem. So what we need to do, we need to find A dot dl. A is also a vector and certainly dl is also a vector. So this we need to find. So that will be from A to B. This is the closed line integration. If I break it in open line, so A to B is one of the open line, plus here dl will be different. So dl1 I am writing. Then from B to C, then from C to D, C to B I am writing, C to D, and then from D to A. Okay. So what I am actually doing is that I am calling this length as, here small length I am taking, that is dl1. Here small length I am taking, that is dl2. Here small length I am taking, that is dl3. And here small length I am taking, that is dl4. So what is your dl1? What do you think? What is changing here? Rho is constant. At point A, what is rho? 2 meter. This complete is 2 meter, no? 2 meter, 2 meter, 2 meter. At point A, rho is 2 meter. Here also it is 2 meter. Here it is 5 meter. And here it is 5 meter. So rho is constant. Z is not even there. All is happening on one plane only, on xy plane only. So Z is not even there. Forget about Z. What is changing then? Phi is changing. At point A, phi is 60 degree, and at point B, phi is 30 degree. And you are going from A to B. You are going from 60 degree to 30 degree. So phi is changing. So what will be your dl? D phi? Sorry, rho d phi. When phi changes, what is the length you need to cover? Here only we saw, no? If phi changes, the length we cover is rho d phi. The length we cover is rho d phi a phi cap. And rho is constant here. Rho is 2. Let me remove it, otherwise diagram will not look good. So rho is 2. So my dl1 is 2 d phi a phi cap. Okay. So if I need to calculate from A to B, I am going A dot dl. Then A dot dl. Rho cos phi a rho cap plus sin phi a phi cap dot dl, that would be 2 d phi a phi cap. So first solve the dot product. A phi dot a phi will be 1. A phi dot a rho will be 0. Again, a rho dot a phi will be 0. A phi dot a phi will be 1. So only I need to consider this sin term. This term will be gone to 0. So what I am getting? 2 sin phi d phi. And the limit of phi will be from where to where? You are going from 60 degree to 30 degree. 60 degree to 30 degree. Look, I wrote A. This was your A. What is my dl? Rho d phi. Rho is constant here, that is 2. So 2 d phi I have put here. 2 d phi I have put here. Then first I will solve the dot product. A rho dot a phi is 0. A phi dot a phi, that is 1. So 2 sin phi d phi. Okay. So A to B, A dot dl1 I am writing here. No, dl1. So A dot dl1. What is that? A to B I am going, that means I am going from 60 degree to 30 degree. Then 2 sin phi d phi. 2 sin phi d phi. 2 will come outward. Integration of sine is minus cos, right? And then 60 degree to 30 degree. You can write 2 cos 60 degree minus cos 30 degree. So this answer will come positive only. Cos 60, that would be root 3 by 2 minus 1 by 2. What you are going to get? Root 3 minus 1. Not the complete answer, but one of the answer that you require. This is your one of the answer that you require. So from A to B you have went. Now you will go to B to C. B to C, A dot DL2 you need to calculate. What is your DL2? You should be able to write it down. That is D rho A rho cap. DL2. What is changing here? Rho is changing. Phi is constant at 30 degree. Phi is constant at 30 degree. Sorry. From B to C you are going, yes. Phi is constant at 30 degree. From B to C I am going, phi is constant at 30 degree. Rho is changing from 2 to 5. Rho is changing from 2 to 5. And Z is not even there, so forget about Z. Z is not even there. So DL2 will be D rho A rho cap. So from B to C I am going A dot DL2. So what is my DL2? Here it is D rho cap. So first I will write down A. What is my A? Rho cos phi A rho cap. From next time onwards I am not gonna write complete expression. You will have to understand which dot product will go to 0. Here also you should be easily able to understand which dot product will go to 0. Rho cos phi A rho cap plus sin phi A phi cap dot DL. DL is D rho A rho cap. So A phi dot A rho cap, that will go to 0, and A rho that will make 1. Well and good. And what will be the limit of rho? From 2 to 5 we are going. From B to C, from 2 to 5 we are going. And phi is 30 degree, so I can put 30 degree here. Okay. So cos 30 will come outward. Rho D rho. Rho equals to 2 to 5 we are going. Root 3 by 2. Rho square by 2. From 2 to 5 we are going. From 2 to 5 we are going. So root 3 by 4. 25 minus 4 is 21. So this is also one of the answer you need. Again, rho cos 30 D rho. Cos 30 will come outward. Okay, that is root 3 by 2. Right? Root 3 by 2. Rho square by 2. Okay, so root 3 by 4. So 25 minus 4, 21. So this is the other answer. Let's see more now. Now I need to work from D to A. What will be your DL4? That also be D rho only. DL4 will also be D rho only. There is no doubt about that. Right? Someone will write minus D rho. Do you think you should write minus D rho there? If you write minus D rho cap, then you will put the limit from 2 to 5. And if I am writing D rho, that means I will put the limit from 5 to 2. What I am saying is that here what is changing? Rho is changing. Rho is decreasing. So some people might think that, sir, I should put minus D rho cap. Minus D rho A rho cap. This is what I should put, because rho is decreasing here. Then why didn't you get this doubt that, sir, here also I should put a 60 to 30? Since it is an offline class, sorry, since it is a recorded class, here also you should have got this doubt. But no, always take a positive limit you are going to put, no, from 5 to 2. So that will itself come negative. So there is no doubt about that. Okay, you do not need to put a minus sign. That's why this will show in minus direction. That you do not need to do. Well and good. A to B, B to C, C to D. Okay, I am not going from D to A, I am going from C to D now. C to D और रह गया ना, C to D. A DL3. So what is your DL3? DL3 is rho D phi A phi cap. Okay, I will take a pause. You try to solve it on your own, then I will restart. Yeah, so let's continue this problem now. So this was the DL3 we have wrote, rho D phi. Now from C to D you are going A dot DL3. Now I will write down the expression directly. A phi cap I need to see. A phi cap. So arrow dot A phi cap will be 0. So this will have no use. Only sin phi term will come. Sin phi integration will certainly be there. Sin phi into rho d phi. So rho I can write down initially. Rho I can write down initially into rho d phi. The value of rho is constant, which is equals to what? Here what is the value of rho? On CD, value of rho is 5. So here value of rho is 5. Value of rho is constant, that is equals to 5. So this rho will come outward, this 5 will come here. And from where to where phi is going? If I am working on this path, so phi is going from 30 to 60 degree. 30 degree to 60 degree. And one more error I did here. So this would be 1 by 2, no? Cos 60 is 1 by 2, right? 1 by 2, and this is minus root 3 by 2. So this would be 1 minus root 3. 1 minus root 3. 5. Cos phi. Integration of sine is minus cos phi. But I will change the limit. 60 to 30 degree. So 5 cos 30. What is cos 30? Root 3 by 2 minus 1 by 2. 5 by 2. This time I did it correctly. Yes. Root 3 minus 1. This question is directly from Sadiko's book. Okay. So these kind of calculation error could be there in these kind of big questions. So in the examination you should have good amount of concentration. Now I know some people will be having the doubt of a direction, that sir, you are taking sir this direction as a phi, right? You are saying that sir this direction is a phi. Now you are working from C to D, then sir you are working in minus a phi, no? If I am working from C to D, then here you should write minus a phi. This doubt a lot of people would be having, that sir here minus sign should come. Let's just say I am working in a phi only, okay? If I am working in a phi only, this is what I am saying. I am working on C to D, but I am working in a phi only. So what will be the DL I will be writing? DL will be rho d phi a phi cap, right? Forget about all these things, okay? Just one thing I am explaining, which a lot of people might be having this doubt. So this is the DL I am writing, that I am working in a phi. Then what will be my A dot DL? This I am talking about DL3. So what will be my A dot DL3? So a phi rho sin phi d phi. On which path I need to go? From 60 to, if I am working in a phi, that means my limit will be from 60 to 30 degree, not from 30 to 60. Are you getting this point? If I am working in a phi, that means my limit has to be from 60 to 30 degree. Look, anything you can take a phi. This direction also you could have taken a phi. But for consideration, I am taking this as a phi. If I am taking this as a phi, you are happy with this. Because sir, if this is your a phi, then rho d phi a phi, and your limit was going from 60 to 30 degree. Now again I am working in a phi direction. Then what will be my limit? In this direction, my limit will be from 60 to 30 degree only. If I am saying that I am working in a phi, then my limit will be from 60 degree to 30 degree only. But you are not supposed to work in this direction. You are supposed to work in opposite direction. So there will be a negative sign also. You need to see this arrow as well, that you are supposed to work in the opposite direction. So there will be a negative sign arrow as well. So there will be a negative sign as well. And if I compensate this negative sign, what I will get? From 30 to 60. So in the examination, you are not going to think this much. Okay. So if I do 30 to 60, rho sin phi d phi, what I am going to get? The same thing. Rho sin phi d phi 30 to 60. So in the examination, you will not have this doubt. This was just a doubt that I wanted to clear. In the examination, you will not think this much. What do you need to think? Just walk on the path. Always take the positive sign of the vector. Always take the positive sign of the vector. Whether you are working in the increasing direction or you are working in the decreasing direction, the sign will be compensated by the limit. What I am saying, always take a phi cap only, always take arrow cap only, always take az cap only. If you are thinking that you are decreasing or increasing, that will be compensated by limit. Are you getting this point? Here the limit was 60 to 30. Answer became 1 minus root 3. It was negative. Here the answer is becoming positive. Are you getting this point? So the limit will compensate the sign. Here I proved it as well. That let's just say if this is a phi, I am working in a phi only. So what I am writing, rho d phi a phi. Then I put the limit. But which limit I will put? If I am working in a phi, that means 60 to 30 degree I will put. 60 to 30 degree. But 60 to 30 degree limit if I put, you are working in a phi, but you are supposed to work in this opposite direction. So now minus sign also I will have to put. And then minus sign will compensate, it will make from 30 to 60 degree. If you are not understanding this, then also there is no issue. In the examination, you always need to take positive unit vector. And if you, when you put the limit, it will be compensated. So this is a very good doubt. Some student might be having it. I hope I have cleared it. Okay. You are not going to find these things in the textbook. These kind of things you need to think on your own. I also thought of it. I also had this doubt. Then I thought, what is actually happening? If I work in a phi, then negative sign is compensating that. So in the examination, in all the questions, you just need to work in the given direction and always take the positive sign of the unit vector, right? Okay. Then C to D I have worked. Now I am gonna work from D to A. So here you will think that, sir, rho is decreasing. So shall I put minus D rho cap? Sorry, minus D rho arrow cap. No, you will put D rho arrow cap only. Here rho is decreasing. So some people would say that, sir, minus arrow cap I will put. But if you put minus arrow cap, then you need to put the limit from 2 to 5, not from 5 to 2. If you are putting minus arrow cap, that means you are working in this direction, then you need to put the limit from 2 to 5, not from 5 to 2. Okay. So this we are not going to do. We will always take the positive unit vector. The limit will be compensated. I am going from D to A, so I will put the limit from 5 to 2. So that will compensate it. So D to A dot DL4. Right? So this I need to find. What is my DL4? DL4 is rho D phi. Sorry. DL4 is D rho cap. D rho arrow cap. Okay. So D to A dot DL4. D to A I will not put now. So D rho arrow cap is there. So rho cos phi, that term will come. Rho cos phi. Rho cos phi. And DL is D rho. What is the value of phi here? Phi is constant. On this graph, on this D to A, if you are going from D to A, phi is constant, that is equal to 60 degree. So phi is constant. So phi is equal to 60 degree, that is constant. So phi equals to 60 degree I will put here. And value of rho you are getting from 5 to 2. Value of rho is from 5 to 2. From 5 to 2. Okay. 1 by 2 rho square by 2 from 5 to 2. So 1 by 4 minus 25 minus 21 by 4. Right. This will be minus 21 by 4. Now what I need to do? I need to calculate the complete addition. So A dot DL. The addition I need to do. So 1 minus root 3 by 4. Then what is the answer? This answer I got, and then this answer I got. I just need to add them up. 1 minus root 3 plus root 3 by 4 into 21 plus root 3 by 4 into 21 plus 5 by 2 root 3 minus 5 by 2 plus 5 by 2 root 3 minus 5 by 2 minus 21 by 4. Okay, this calculation you will do 21 root 3 by 4 plus 5 by root 2 minus 5 by 2 minus 21 by 4. This calculation you will do and you will get the answer 4.94. This is the answer. Now you are thinking how we will solve this in the examination. You will be able to solve it very quickly when I teach you the theorem. But I do not want to teach you the theorem directly. If I directly teach you the theorem, you are never going to solve by the line integration. But in the examination, it might happen that you need to solve the problem by line integration only, because theorems are not always applicable. There are certain things, there are certain rules where the theorem will not be applicable. So there you will have to follow the line integration only. That's why I am building up the concept. Same problems we are going to solve by the theorem as well. But we need to build up this concept as well, right? Now volume integral. So we will understand this by example only. So total charge contained by the volume. This is what you need to find. What is this? This is a cylinder. Rho is changing from 0 to 2, phi is changing from 0 to pi by 2, and z is changing from 0 to 3. Did you understand? Phi is only changing from 0 to pi by 2. Did you understand what kind of volume it would be? Phi is only changing from 0 to pi by 2. 0 to only pi by 2. So only this much phi is changing. So I will try to make the cylinder. Right, so this kind of cylinder is that there. So this was angle 0 and this was angle pi by 2. Okay, the limit of rho is from 0 to 2. 0 to 2. Rho is equals to 0 here, rho equals to 2 here, and phi limit is 0 to pi by 2, and z limit is z equals to 0 here and z equals to 3 here, from 0 to 3. Volume charge density is 4xyz. Okay, you need to find the total charge contained by the volume. So what did you understand by volume charge density? That in 1 meter cube 4xyz, this much Coulomb charge is there. So in dV meter cube, how much charge will be there? 4xyz dV Coulomb charge is there. Say yes or no. In 1 meter cube this much charge is there, in dV meter cube this much charge is there. If I need to find the total charge, what I need to do? Simply the integration. 4xyz into dV. Limit I will put, limit are from rho is 0 to 2, phi is 0 to pi by 2, and z is 0 to 3. But what is the catch here? This is in xyz. Can I change it? Yes, very easy. What will be your dV? First tell me, what will be your dV? Do you remember? How do we write down dV? First we will write down dl. That will be d rho aero cap plus rho d phi a phi cap. Again I am writing aero plus a phi cap plus dz az cap. So what will be your dV? Simply the multiplication of all. So rho d phi dz. So this is how we write down dV. So this will be our rho d phi dz. Can I change these values? 4xyz. Yes, x equals to rho cos phi, y equals to, all are changing in the volume, all are changing. Rho is also changing, phi is also changing, z is also changing. So I am not going to put any value here. I will put it here, then I will put all the limits. Y is equals to rho sin phi and z is equals to z only. So let's find out the total charge. Or rho cos phi x into y into z. So rho square sin phi cos phi z. Rho square sin phi cos phi z, right, into what is dV? dV is rho d phi dz. So rho d phi dz. Okay, what I can do now? I will multiply 2 here and divide by 2 here. Multiplied by 2 divided by 2. Let's see what do we get. Limit we will put later on. So what I am gonna get is that 2 rho cube, this row and this row, rho cube, and 2 and 4. Okay, 2 rho cube This is your sine 2 phi, right? Yes. Yeah, sine 2 phi. Sine 2 phi is 2 sine phi cos phi. I hope you remember this formula. Sine 2 theta is equals to 2 cos theta sine theta, or 2 sine theta cos theta. Okay. So this 2 got cancelled. 2 rho cube sine 2 phi, z is there as it is, d rho, d phi and dz. Now what did you get to know? Rho limit you can put aside. So limit of rho is going from 0 to 2. Rho is going from 0 to 2. What about phi? Phi is going from 0 to pi by 2, and z is going from 0 to 3. Okay. So 2 rho to the power 4 by 4, that will make rho to the power 4 by 2 from 0 to 2, right? From 0 to 2. Simple integration I am doing, nothing else. Sin phi cos 2 phi divided by 2. Always you need to take patience here, and then negative sign will also come. So I will just interchange the limit from pi by 2 to 0. Sin phi integration will be minus cos 2 phi and divided by 2. Negative sign will come, I just interchange the limit, and here you will get z square by 2 from 0 to 3. 8 2 9 by 2, 72 Coulomb. So this is the answer I am getting. Yeah, so I noticed a small error from my side, which was here. Okay, even after checking the calculation, I am getting the answer wrong. Now you might be thinking how this guy got AIR 27. He does so much of minor mistake. I did so much of minor mistake in my final examination as well. Okay, the calculation mistake, that is one of my issue. In the final examination as well, I did calculation mistake. Like at least 10 marks I lost because of the calculation mistake only. At least 10 marks. Can you believe it? Like these kind of minor calculation mistake. I was able to solve very tough problems as well. Like even I was able to solve so kind of problem. I am not flexing it, but even I was able to solve those problems which were given wrong by a lot of institute at that time when I was an aspirant. I am not flexing it, but I was able to solve those problems. But because of minor mistake, I lost at least 10 marks. At least I am telling it. So yeah, this kind of mistake I do. Look, here it was by 2. I forgot to do the by 2. I put cos 0 minus 1, cos pi minus, and then you think that sir, how cos 0 is 1 and then this is minus 1. Then you think that sir, how we will be able to do well in the examination? You will be able to do well in the examination. All the toppers do the minor mistake as well. Okay, so this is one of the example for you. And here what will be the answer? 36 Coulomb. Did you understand this point? The answer will be 36 Coulomb. If you put cos 0 here, that would be 1, 1 minus 1, 2, 2 by 2 will be 1. So 36 Coulomb will be the answer. Let's solve the questions now. So you need to solve this question. H dot dl you need to find along the curve y equals to x square. Let's see the meaning of this. So first make the curve y equals to x square. So this is your y coordinate, y x. So y equals to x square equals to 4ay. Sorry, y equals to 4ax. This curve I know. This will look like this. So y equals to x square, that will look like this, right? So I can make it better. This will be your y equals to x square. So what they are saying is that there are vector field lines available. This is your vector field lines, which is depending on x and y. So these are the vector field lines available. So this is the vector field lines. This is the rough diagram I am drawing. This is not the exact diagram. So these are some vector field lines. It could be like this as well. Anywhere it could be. So in the presence of this vector field line, you need to walk from 0, 0 to 1, 1 along this path. This is what it means. Again I am repeating. In the presence of these vector field lines, you need to walk from 0, 0 to 1, 1 along this path. Are you getting this point? You can walk from 0, 0 to 1, 1 in this direction as well. You can walk from 0, 0 to 1, 1 like this as well. You can walk from 0, 0 to 1, 1 like this as well. So they have defined the path. Which path you need to follow? Y equals to x square. That means this path you need to follow. So you need to walk from 0, 0 to 1, 1 along this path. So along this path, what is changing? In the previous questions, always only one thing was changing. Here D row was, here row was changing, here here 5 was changing, here row was changing, here 5 was changing, here row was changing. So only one thing was changing. On this particular path, okay, I don't even have the next page. Okay, so on this particular path, what all are changing? X is also changing, Y is also changing, right? From here to here, X and Y both are changing. So how will you write down your DL? DL I will write down in this manner: dx ax cap plus dy ay cap, because both are changing. Okay, now what I need to do? First thing is that I need to add a page. So what I need to do? I need to write down h dot dl. What is my h? Here I am not gonna put this, okay, because this is not closed line integration. Where it is closed line, this is open line only. So this is not closed line integration. In the previous question as well, here I put it. Okay, there will be more questions where we are not going to put a closed line integration. This is open line integration. So this I am not gonna put. I will show the curve L. L is y equals to x square. So this I need to do. So what is my h? X square ax plus y square ay. X square ax plus y square ay dot dl. dl is dx ax cap plus dy ay cap. So if you solve it, what you are going to get? Ax cap will be multiplied with x cap, ay cap will be multiplied with ay cap. So x square dot dx plus y square dot dy. Now what is the common mistake that you can do? Mistake I am telling. What you will think that, sir, x is changing from 0 to 1 and y is changing from 0 to 1. So now I can put the limits that x is changing from 0 to 1 and y is changing from 0 to 1. Then sir, I can solve it. What you are going to get? 1 by 3 plus 1 by 3, 0.67. Luckily you got the correct answer here. But luckily you got it correct. Okay, this thing is wrong. Why this is wrong? Because your y is depending on x. No, your y is a function of x. Y is equals to x square. Y is equals to x square. So what will be your dy? Dy will be 2x dx. So this is one of the things you can do, that you can change your dy now. You change your dy by 2x dx. So what is the, till this point we have reached? Till this point we have reached x square dx. I am not going to change x square dx at all. Okay, plus y square dy. So in place of y square I am going to put x, in place of y I am going to put x square. So what I am going to get? X square square. And what is your dy? Dy is 2x dx. Now the whole function is coming in one term, that is x only. Now I can put the limit of x, that is from 0 to 1. Are you getting this point? Okay. So x square dx plus 2x to the power 4 into dx. Limit of x is from 0 to 1. This is x to the power 5 actually. This will be x to the power 5, right? X to the power 4 into x to the power 5. So x to the power 3 by 3 plus x to the, this will be 2x to the power 6 by 6. 2x to the power 6 by 6. And from where to where you are going? From 0 to 1 you are going. So 1 by 3 plus 1 by 3. 0.2 by 3, that is 0.67. So this is the correct method. Here you got the answer correctly, but luckily, why this is not correct? Because your y is a function of x. Also you can say my x is a function of y. So what could be the other method? This was one of the wrong method. So this was one of the wrong method. Okay. Then we saw this particular method which was correct. Now we can see one more method. I can change x now. I can change x as well, right? So y is equals to x square is given. So dy is equals to 2x dx Now I need to change dx. So what I will get? dy by 2x. dy by 2x. So what I can write? dy by 2. What is x? X is root y. X is root y. What is your x? X is root y. So what I will get? What is x square? X square is equals to y. What is dy? What is dx? Dx is dy divided by 2 root y plus y square dy. What is the limit of y? Y is going from 0 to 1. 0 to 1. So root y by 2. So directly I am writing the result now. Okay. So this is y, this is root y. Here you will get root y by 2 integration from 0 to 1. What that will be? Y to the power 3 by 2 divided by 3 by 2 from 0 to 1. Okay. So 1 by 3 you are going to get. 1 by 3. Here you are going to get 1 by 3. So result of this integration will be 1 by 3. From here to here I am going. So result of this integration will be 1 by 3. Simply the integration you need to do, and this will be y cube by 3. So from 0 to 1 again it will be 1 by 3. So what is the answer you are getting? 0.67. That is the answer you are getting. Okay. So if you had applied this method, that is wrong. Now you can interchange in anything. Here root will come, so I will not prefer this method, I will prefer this method. Y equals to x square dy, and then in one function only I have made everything. I have made all the expression in the function of x. So 0.67. Here also 0.67. Let's see this question. I think you were able to solve this particular problem at least. You should be able to solve this particular problem after this much of practice. Okay. So let's start now. Vector A is given. You need to walk around the edge. Like you need to walk around this. In this manner you need to walk around. And rho is changing from 0 to 2. Rho is changing from 0 to 2. This is your rho. Rho is changing from 0 to 2. And then phi is changing from 0 to 60 degree, and z is 0 only. Z is 0. These information are given. Okay. So let's start. Can I write down the closed line integration here? Yes. Because this is framing a closed loop. So I can write down closed line integration. A dot dl. This I need to find. There are three paths. dl1, dl2 and dl3, right? So that can be broken into three paths. A dot dl1 plus A dot dl2 plus A dot dl3. What is your dl1? What is your dl1? dl1 is 0 arrow cap, right? dl1 is 0 arrow cap. So A dot dl1, that is rho cos phi arrow cap, dot 0 arrow cap. So this is the answer I am getting. Rho equals to 0 to 2. What is the value of phi here? For dl1, what is the value of phi? Phi is 0 degree. For dl1, phi is 0 degree. From 0 to 60 it is going. So here phi is 0 degree only. So phi is 0 degree. Cos phi is 1. So what you are getting? Rho square by 2 from 0 to 2. Answer is 2. Okay. So till here you are getting 2. What do you think what you are going to get in place of dl2? How did I write rho cos phi d phi? I hope you are able to understand. Arrow dot arrow is 1. Arrow dot az is 0. So I forgot this term. I did not write this term. I only wrote this term. Right? Now, what is your dl2? What is changing? Phi is changing. That means rho d phi a phi. Rho d phi a phi cap. So what I need to do? A dot dl2. Is there any term of phi here? What you are going to do? Rho d phi, you are going to do the dot product of a phi with this value. So arrow dot a phi 0. Az dot A5 0. So dot product is also coming 0. So answer will be 0. Are you getting this point? This was one of the answer. This is the second answer. Why second answer is 0? Because you are going to do the dot product A5 with this value. Aero dot A5 0. Az dot A5 0 only. Now let's go to DL3. What will be your DL3? Again, what is changing? Rho is changing. Rho is coming from 2 to 0. So d rho, aero cap. Okay, d rho, aero cap. So now A dot DL3. So I will multiply with aero dot aero cap 1, Az dot aero cap 0. So rho cos phi, rho cos phi d rho, and rho is changing from 2 to 0. Limit is from 2 to you are coming to 0. Okay, phi value. What is the value of phi? What is the value of phi here? 60 degree. What is the value of phi here? 60 degree. So 60 degree I will put. So cos 60 degree, rho equals to 2 to this integration I can do. That will be rho square by 2 from 2 to 0. So cos 60 is 1 by 2, and then 0 minus 4 minus 2. So answer is minus 1. This answer is minus 1. This is 2. This is 0. So answer is here minus 1. So what is the complete integration? A dot dl 2 plus 0 minus 1. 1 is the answer. Very easy question, very straightforward. Just I have told you in that manner only you need to go. Whatever that is directed, you just need to solve in that manner. You will be certainly able to solve the problems in the examination as well. And these kind of problems are very, very tough for a student. You can ask any of your friends. They will say like, this is very tough. But no, this is not tough. This is very straightforward. Okay. Let's solve this question. Try doing it on your own. So there are 3 paths. You need to go here, here and here. Okay. So I will name these points. I will go from A to B, B to C and C to D. H dot dl I need to make. Can I make this sign? No, because this path is not framing a closed loop. Can I make this sign? No, because this path is not framing a closed loop, right? It has to frame a closed loop, then only I can do this. Okay, so this is open line integration. This is open line integration. This is not closed line integration. Okay, so H dot dl I need to do. So for A to B, what is changing? Only x is changing. For A to B, what is your dl1? Only x is changing. So dx ax cap. So I am writing this is your dl1, this is your dl2, and this is your dl3. So dl1 is dx ax cap. Now H dot dl. X minus y into dx. On this curve, what is the value of y? On this curve, not curve, on this line, what is the value of y? 0. You are working on x axis. So what is the value of y? 0 only, no? So here the value of y is 0. So I can put y equals to 0, and x is changing from 1 to 0. X is changing from 1 to 0, and the value of y is 0. So x dx from 1 to 0. X square by 2 from 1 to 0. So minus 1 by 2. Here I should not write h dot dl, I should have written h dot dl1. H dot dl1. Now I will talk about h dot dl2. This I need to find. This I need to find. So what is your dl2? dl2 is dy. Sorry, dz. dl2 is dz, right? Only z is changing. dz, always you will take positive unit vector. Okay. So h dot dl2. So dot az. So 5 yz. 5 yz. 5 yz Because I am doing the dot product with AZ only, so this will be 0, this will also be 0, only this will come in action. So 5YZ into DZ, 5YZ into DZ. The limit of Z will go from 0 to 1. But what is the catch here? Limit of Z will go from 0 to 1. What is the issue here? On this line, what is the value of Y? On this particular line, what is the value of Y? Tell me. You are working on Z axis. You are working on Z axis only. So what is the value of Y? Y is 0. Here the value of Y is 0. So if value of Y is 0, so here you will put 0 only. So 5 into 0 into Z into dZ. So Z value from 0 to 1. What is the answer? 0 only. Now DL3, which is very interesting, and for that I need to add a page as well. Not interesting, it will just test your calculation. So now next I need to calculate H dot DL3. So calculation will be there. So what will be your DL3? First tell me. What is changing? Z is also changing and Y is also changing. When you are working here, so Z is also changing and Y is also changing. Y is also changing and Z is also changing. Right? Z is changing in this direction, Y is changing in this direction. So what I am gonna write? Y is also changing and Z is also changing. Okay. So H dot DL3. So whatever H is there, dot dy ay cap dot dz az cap. So y will be multiplied with y, z will be multiplied with z. So x square plus zy ay cap, x square plus zy ay cap dot dy ay cap. So what will happen? Dot dy. I hope you are able to understand this. What did I do here? I hope you are able to understand this. Plus what? 5yz, 5yz dz. Say yes or no? 5yz dz, 5yz dz dot dz. I hope you are able to understand. The function was there. I just did dy ay cap plus dz az cap. So ay dot ay will be 1, az dot az will be 1. Ax term will not even come. This term will not even come. Now what is the scene here? In DL3, y and z were changing. But when you are working on yz plane, what is your x? If I am working on yz plane, what is your x? X is 0. I am not even working in x. So x is 0 only. So x is equals to 0 here. So here I can put 0. So what will be my final expression? So that will be zy dy plus 5yz dz. But what is the scene? You need to take this in one variable only. So either I can put in z or I can put in y. So first write down the relation between z and y. How will you write down the relation between z and y? You need to write down the relation between z and y. So this is a straight line, right? This is a straight line. I hope this much basic you know. This is a straight line. I just need to write down the equation of a straight line. This was your z axis, this was your y axis. Y is equals to 0 but z equals to 1. Y is equals to 2 but z equals to 0, right? Yeah. Okay, so what will be the equation of this line? Z equals to the slope. What is the slope? Slope is minus 1 by 2. Y plus how much you cut on z axis, that is 1. So this will be the equation. Y equals to mx plus c. Y equals to mx plus c. Slope and how much you cut on z axis. So one length you are cutting on z axis from the origin. That will be, this will be the equation. In any way you can write it down. Okay. So what I am gonna do is that my y will be 2 into 1 minus z, right? So my dy will be minus 2 dz. So this is how I am gonna replace. I am gonna replace y with z. So let's start now. So z into y. What is my y? That is 2 into 1 minus z. And what is my dy? Dy is minus 2 dz. plus 5yz dz. 5. What is y? Y is 2 into 1 minus z into dz. Limit of z. Z is going from 1 to 0 or 0 to 1. What do you think? What was the arrow direction? This was the arrow direction. So here z was 1. You are going from 1 to 0. I am talking about z only because complete function has been made in one variable, that is z. So you are working from 1 to 0. 1 to 0. Right? Not 0 to 1. Z value was 1 here. Here it is 0. From z to 0. Okay. So let's solve it. Did I forget anything? 5, 2 into 1 minus z, and then z is also there, no? Z is also there. Okay. So z equals to 1 to 0. So this is becoming minus 4 z into 1 minus z plus tan into z into 1 minus z into dz. Z equals to 1 to 0. This is tan z into 1 minus z. This is minus 4 z into 1 minus z. So it will become 6 z into 1 minus z into dz. This will be z from 1 to 0. 6z into dz minus z equals to 1 to 0. 6z square dz. 3z square minus 2z square, 2z cube. This will be 6z square by 2. So 3z square minus this will be 6z cube by 3. That will be 2z cube. From z equals to 1 to 0. So this will be minus 1. So this is the third answer you are getting, that is minus 1. So here you are getting minus 1, this was you are getting 0, and this you are getting minus 1 by 2. So what is your h dot dl? So here is my answer, which is h dot dl, which is what? Minus 1 by 2 plus 0 minus 1, that is minus 1.5. So this is my final answer. Okay, easily I am solving everything. Try doing this question. Can you try making the structure first? Find the volume cut from the sphere of radius A by the cone theta equals to alpha. So theta value, they are giving two value. First is theta equals to pi by 3. So from a full sphere, you are cutting some part where r is a and theta equals to pi by 3. Phi is complete 0 to 2 pi. Phi is complete 0 to 2 pi. This sphere has a radius of a and you are cutting it at theta equals to pi by 3. Can you think of this structure? If you are not able to think of this structure, at least try thinking of the structure when theta is equals to pi by 2. What is your theta? Angle made from z axis, right? Angle made from z axis from top to bottom. So there will be a lot of angles, no? Pi by 2. A lot of angles will be there. Behind there as well. Like behind there as well, pi by 2 angles will be there. Are you getting this point? I will just make the structure and you will feel like that, sir, I already knew it. I don't know why I couldn't make it. So just now I will make the structure. I can drop this globe. And you will get this cube only, no? Are you getting this point? Not cube. Did I say cube? No. Cone. You will get this cone only, no? Did you understand this point? Look, this is my z axis. Theta equals to pi by 3. Around, let's just say this is z axis. No. This is your z axis. So pi by 3. Around this line there will be a lot of pi by 3 angle, no? So all pi by 3 angle. Radius is r equals to a only. radius is r equals to a only. All these are pi by 3 angle. This is pi by 3, and here also there will be pi by 3, not pi by 2, pi by 3. Here also there will be pi by 3. So all these are, here also there will be pi by 3 on this direction. So all these are pi by 3 angle. Like I can make this structure like this. It will make you more clear. So all these are pi by 3 angle. On the behind as well, pi by 3. Behind as well there is pi by 3. Pi by 3. Pi by 3. Pi by 3, pi by 3 angle. But why did I make like this? No. There should be curve as well, no? Look. There is some mistake in this diagram. What is that? It should be curved because this is a part of a sphere. So there one curve will also come. Let me make it more clear. It will be like a ice cream type structure. If I cut this here, so yeah, it will be like a ice cream type structure. Are you able to understand this? If I cut it from right in between, it will be a hemisphere, but I am cutting like this. So this kind of structure it will be. You need to find the volume. Although this is not necessary, this diagram is not necessary for finding the answer, but still I am telling how it will look. Are you able to understand this point? From z axis, all pi by 3 angles. Here, why did I make this? That was wrong. This will not, from upper side you are not cutting it, no. This will be a complete like ice cream type structure. Okay. Now, how to solve this question? There you do not need to do it. So what we need to do? We just need to find the volume. What is the volume of a sphere? How do we write it? dr r d theta r sin theta d phi, right? dr r d theta r sin theta d phi. So what will be the volume? R square sin theta dr d theta d phi. So what will be the first one? What will be the complete volume? dV. R square sin theta dr d theta d phi. So r is going from 0 to e. Phi is complete, or theta value I can put. Theta is going from 0 to pi by 3. And phi is also from 0 to 2 pi. Phi is complete 0 to 2 pi. Fair or no? Right? So r square dr will be r cube by 3. First I am solving the limit of r cube by 3 from 0 to a. Then solving theta. So sin theta cos theta 0 to pi by 3. But I will change the limit because sin theta, integration of sin theta is minus cos theta from pi by 3 to 0. And d phi, so this will be 2 pi. Okay. A cube by 3 into here cos 0 is 1 minus cos 60 theta is from 0 to pi by 3. Okay, it is cos 60. Cos 60 is 1 by 2 and this is your 2 pi. So what you are getting? 2 pi a cube by 3. Yeah, so that's the answer, pi a cube by 3. Let's see the b part of it. So b part of it will be the same only, just this limit will change, right? This alpha value will change. Alpha will be pi by 2 and it will look like a hemisphere. Are you getting this point? This theta value will be pi by 2. Theta is equals to alpha only. So theta value will be pi by 2. So it will look like a hemisphere, right? So all these will be same. A cube by 3, this will be same. Then this 2 pi, that will be same. Just this limit will change from pi by 2 to 0. So cos 0 is 1, cos pi by 2 is 0. So it will be 1 only. So what will be the answer? 2 pi a cube by 3. This you should do on your own only, right? It is very easy, very straightforward. So this is the answer for the second one. This is the answer for first. Let's see the next one. Try doing it on your own. What the question is saying, try reading the language of the question and then try making the diagram. Once you are able to make the diagram, then it will be very easy for you. So what this question is saying, a vector field f is there. You need to find f dot dl along a curve. So that curve you need to make. So where L is from this point 2, 0 degree, 0. In which coordinate system it is mentioned? Cylindrical, right? Where will be 2, 0 degree, 0? Rho is 2. Angle from x-axis is 0 degree and distance z is also 0. P to Q I need to go. Where is my Q? Q is at 2, pi by 4, 3. So angle made from x-axis by the projection, z length of z is 3. So it will be somewhere here. 2, distance is 2. From the origin distance is 2, pi by 4 and length is 3. So if you take the projection, on xy plane and join it with the origin, then the angle made from x-axis will be pi by 4. This is what they are saying, and this length will be 2. Okay, you are going, sorry, this point was P, other point was Q. This point was P, this point was Q. Now how you need to walk? From P to Q you need to go, but how you will go? So what they are saying, assume L consists of the arc rho equals to 2. When phi is from 0 to pi by 4, phi is from 0 to pi by 4, phi is from 0 to pi by 4. Which angle is pi by 4? This angle is pi by 4. Here I am writing is this angle is pi by 4. So phi is between 0 to pi by 4, z is 0 and rho equals to 2. That means this arc you need to go. This arc you need to walk. Okay, this is an arc, this arc you need to walk. And then followed by the line rho equals to 2. Rho is fixed at 2. Phi equals to pi by 4. Phi is also fixed. Z is variable from 0 to 3. So Z is variable from 0 to 3. So this is how you need to walk. On this curve and on this line, this is how you need to walk in this manner. Point P they have given, point Q they have given. Then they told you that you need to go from P to Q. Now how you will go? Along an arc which is rho equals to 2, phi is changing and Z is fixed at 0. So this is the arc. And then what is changing? Z is changing, rho equals to 2, phi is equals to pi by 4 and Z is changing from 0 to 3. So this is the curve. So you need to walk along this curve L. This is your curve L. What you need to find? F dot dl. So there are two paths. I will take dl1. I will take dl1 and other one I will take dl2. So there are two paths. First I will find f dot dl1, then I will find f dot dl2. So f dot dl1 I need to find. So what will be my dl1? What do you think? What is changing? Phi is changing. Phi is changing. Rho is fixed, z is fixed. Phi is changing. So dl1 will be rho d phi a phi cap. Right? Now what do I need to find? F dot dl1. So what that would be? A phi. Only this term will come because a phi dot a rho 0, a phi dot az 0, a phi dot a phi will be 1. So z into rho d phi. But here z is also fixed, no? In dl1 z is fixed at 0 and rho is fixed at 2. Z is fixed at 0 and rho is fixed at 2. So value of z I can put here. So if I put the value of z, z is 0, rho is 2, d phi. What will be the answer? 0. So for this answer is 0 for this curve. Now you need to find f dot dl2. Now in dl2 what is changing? Z is changing. In dl2 z is changing. So it would be dz az cap. Right? What all is fixed? What is fixed that you do not need to write as of now? First write down f dot dl2. F dot dl2. What that would be? Only with az term it will be multiplied. So only with cos phi it will be multiplied. So cos phi dz. Limit of z you are going to put, z is going from 0 to 3. Cos phi, phi is fixed. I don't need the value of rho here, although rho is also fixed, rho is equals to 2, rho is also fixed, rho equals to 2. But I need the value of phi only, so phi equals to pi by 4, which is fixed. So phi is equals to pi by 4. So it is fixed, phi equals to pi by 4, so here I am going to put pi by 4. And the limit of z is going from 0 to 3. What is the value of cos pi by 4? That is 1 by root 2. And z is going from 0 to 3, so answer will be 3 by root 2. So other integration is coming 3 by root 2. So what will be the final answer? F dot dl. So F dot dl will be 0 plus 3 by root 2, that will be equals to 3 by root 2. That's the final answer. Okay. So it was an easy question. The only concern was you need to make the curve on your own, right? So that's it about this lecture. In the next lecture, we will study these kind of problems only. We will study the same kind of problems, but we will solve the problems using the theorems. And where those theorems will not be applicable, that also we will see. So let's meet in the next lecture. If you found it helpful, do comment down and share your reviews. Thank you very much.